This video is for 11.7.
Sway.
We're going to start with Hero's formula. This formula is for finding the area of triangles when you don't know the height. So when given a triangle like so, what you need to do first is to find the semi-perimeter. And the semi-perimeter is exactly what the word says. It's half of the perimeter. Okay, so the formula for the semi-perimeter is adding up all the sides, so the sum of all the sides divided by 2. Okay, so half of the perimeter. With that, we can go ahead and use Hero's formula to find area of that triangle. So the formula is, you take the square root, and inside the square root, you have the semi-perimeter times the difference between the semi-perimeter and each of the sides of the triangle. Okay, so here I have the semi-perimeter, and in here I have the semi-perimeter subtracting each of the sides, and then you multiply them all together, and then you do the square root of the whole thing, then you get the area of the triangle. So let's go ahead and try this in an example. Here I have a triangle with sides 3, 5, and 6. So first thing I would do is find the semi-perimeter. Again, it's to add up all the sides and divide it by 2. So I have 14 divided by 2, which gives you 7. From then, I can plug that in to the formula. So the formula, Hero's formula, is I have the semi-perimeter to be 7. So I put that in for all the S's, and the A, B, C are just my sides of the triangle. So plugging those in, I have 7 times. You see how each of these quantities is just the difference between the semi-perimeter and each of the sides. So I take 7 minus 3, 7 minus 5, 7 minus 6, and all of that multiplied together, and then multiplied by the original semi-perimeter. So simplifying them all, I have 7 times 4 times 2 times 1. And here, I have to multiply them all and then finding the square root and then simplifying the square root. So the fastest way to do that is just simplify this 4. Square root of 4 is 2, so I can bring that out. 7 and 2 and 1 are all prime, so they're stuck inside. So my area comes out to be 2 radical 14. Let's go on to Brahmagupta's formula. This is just expansion of Hero's formula, and this applies to inscribed quadrilaterals. Not all quadrilaterals, but the ones that are able to be inscribed by a circle. So here is 1, and their sides are A, B, C, D. So same thing with Hero's theorem, Hero's formula. Brahmagupta's formula also requires the semi-perimeter. So the difference is here, this one has 4 sides, so you have A plus B plus C plus D divided by 2. And Brahmagupta's formula is really similar, except now that you don't have an extra semi-perimeter sitting outside. What you have are all 4 of them subtracting each of the sides. Okay, so no more semi-perimeter by itself. That one is now subtracting the extra side, so you have 4 different quantities. Let's look at an example. Here is a quadrilateral inscribed by a circle with sides 4, 4, 5, 7. The semi-perimeter is 4 plus 4 plus 5 plus 7 divided by 2, which gives you 10. Now let's plug them all into the formula. I put 10 in for all the S's, and A, B, C, D are just the sides. So 10 minus 4, 10 minus 4, 10 minus 5, and 10 minus 7, all multiplied together under the radical. So I have 6 times 6 times 5 times 3. Because they're all under the radical, I have to simplify them, moving them out. So I have 6 outside because there were twins here. So 6 goes outside, 5 and 3 stay inside. I have 6 radical 15.